without our calculator, then we're going to do the rest of it on our calculator, okay? So to begin with, when you do a scatter plot, you just put dots. They're not connected into a line or anything like that necessarily. So just go ahead and plot your points. So we're going to start with going over to 1.2. You're just estimating, really. Okay, so over 2 up 1.2, over 4 up 2.2, a little high, or 2.2. Okay, over 6 up 3. Okay, and then over 8, and then up about 3.4, and then over 9 and up about 4.3. Okay, doesn't that look like it kind of makes a line? The line's a little crooked, but it's making a line. Okay, that's a linear relationship. So what we're going to learn how to do is we're going to learn how to do the line of best fit. Okay, so if you'll get your calculator out, I'll show you how we want to put this stuff in then. So first thing, and I showed you this last time, is you press your Stat button, then you press Edit. So you want to enter when it says Edit. And if you have a bunch of stuff in your calculator, like if your great goodie's still in there, you would need to clear it off. First thing is, if you need to clear something up, just get your cursor blinking on L1, plus clear and press enter. Okay, that's the easiest way to clear a list. Like L2, if you got a bunch of stuff like I do, get it blinking, press clear, press enter. Okay, the other thing is, does everybody's calculator say L1 and L2? Okay, because sometimes that's messed up. Students have a calculator that's been messed up from something they've done in the past. So all you do now is put the X values in L1. So I'm just going to do 2, then 4, 6, 8, and 9 like that. So you want to get all of your X values in. Okay, now your Y values are going to go 1.2, and then 2.2, and then 3, and 3.4, and then we'll put in 4.3 like that. Okay, so once you get your data in, now what you do is you follow these keystrokes right here. Is everybody okay with how I'm getting the data in? Is that working? You did the great goodie, so you already kind of learned how to do that. So now do this. Go Stat, press your Stat button, go to where it says Calc. So you just use your right cursor key. Now when you do a linear regression, I think there's two ways to do this. You can do number 4, or you can do number 8. Okay, I think last time what I did was number 8. It's probably better if you do number 4, because what that's saying really is it's saying y equals ax plus b. Well, a is the slope like you've learned, and then b is, of course, the y-intercept. Okay, so what you do is just press that, press enter, and you usually have to go down to calculate. This stuff shows up by default. Your X list is L1, your Y list is L2, so that should show up automatically. Then go down the bottom and do calculate. Okay, and then just press enter when it says calculate, and out will come the answer. Okay, so what you want to do is we would round this to a certain point. So we would have y, let's just round to like 3 decimals. So we'll say y equals 0.406 times x, and then plus 0.465. That would be a good answer of the problem. Okay, is that working for everybody okay? All right. So now I'd like you to do this also. So if you'll go to y equals now, and what we're going to do is we're going to do 2 things. Okay, first thing is you want to go ahead and put in the linear regression equation that we got. We call that a regression equation. So put in 0.406 times x, and then plus 0.465, like that. The other thing you want to have is, remember when you were doing the great goodie, that plot needs to be turned on so the points come on. So what we're going to do with this is get that highlighted and press enter, and then we need to adjust our window so we can see what I want you to see. Okay, everybody with me there okay? Right? Now the window, do exactly what I have on here. Just go, for x, just go 0 to 10, exactly like I have on the graph there, by a scale of 1. And then for the y values, go 0 to 5 by a scale of 1 like that. Okay, now if you press graph, if you're following along doing this correctly, you should see all of your data points. Then you should see a line connecting those dots in a certain way. That's called the line of best fit. And what it tries to do is it tries to get those dots all as close to that line as possible. okay? And you're going to rely on your calculator on this because regression analysis is something usually you learn in an introductory stats class. And that's actually, if you do that by hand, it's a ton of work, okay? So mostly in the modern world, we do regression equations. We let the calculator take over because there's a big kind of arithmetic process that does that. Okay, did everybody follow that okay? You got a question?
When you did the linear regression, what did you put in for?
Okay, I did 4. So what I did is I went stat, then calc, and then I went down to option 4. There's actually 2 of them. It doesn't matter which one you do.
So you just press that and that's
Yeah, you just press enter, okay, is when you do that. And then it should do it automatically. And what it'll do is it will ask you to calculate. On these more modern calculators, you've got to go down to calculate, highlight that, and then press enter, and then it'll give you what A and what B is, okay? Okay, now unless you've got an older calculator, do you have an 84?
I have 83.
Okay, so 83, it might look a little different than that. I think the 84s have you calculate, but is it working okay?
Yeah.
Okay, very good. Okay, all right, so next thing we're going to look at, and this is real simple, is we're going to look at in statistics, and we do this kind of thing all the time in science. We try to plot things and see if they're correlated or not. So what we mean by that, for this class, we're going to look at, well, do they make a line or do they make sort of a line? If you look at this thing right here, that kind of makes a line, doesn't it? The data's a little bit off that line, so we would say that that's a linear relationship, okay? So those things would be highly correlated because they make a straight line, fairly close. It's not perfect. And if you do data in the real world, hardly anything's perfect, okay? All right, how about the next one? Does that make a line for the most part? Yeah, okay, so that's probably linear, okay? All right, how about the next one? No way in the world, okay? That one's nonlinear. Does that look like any function that you've learned this semester?
Yes.
Yeah, it looks quadratic, okay? Now, all we care about is nonlinear, but your calculators actually can do quadratic regressions also, okay? All right, and then the next one, what in the world is that? That's like chaos. So if you were doing a study on, say, for instance, that you were interested in how X relates to Y, if it's everywhere, then it just means they're not correlated, okay? So this one is basically, there's no correlation on this. Okay, it's definitely nonlinear, but it's also no correlation. It's just, okay, there's no relationship whatsoever on that problem, okay? So that kind of stuff's real easy. You'll learn a lot more about that in science classes and statistics if you take that, okay? All right, the next one, if you look at this, which one appears linear, A, B, C, or D, or more than one?
A.
Hey, without a doubt, that's the only one. Okay, that's linear. B is just like no correlation whatsoever. Now, if you look at C, that almost looks like a line, but it really isn't. What it's doing is it's leveling off. Does that look like anything you've learned about? Yeah, which one is that? Square root, right. That one kind of looks like it might be a square root, okay? That's what I'm thinking. And then this one, I don't know, we've seen, so that almost looks like half of a parabola. It might be, okay? So it might be quadratic. I don't know for sure, but the point is it's definitely not linear, okay? So you want to know basically what scatter plots look like and when you have a linear relationship and something that's not linear, okay? That's usually very basic for students to understand. Okay, so next couple of things we're going to do, we're not going to spend a lot more time on this, is let's go ahead and I'm going to have you do some of these just outside of class. So this one right here, and I won't grade it on your notebook if you just write omit there, because I don't want to do these over and over again. Let's go ahead and do something with this. Definitely on number 9. Now let's just go ahead and let's do this on our calculator and get everything put in then, okay? Because this one's got another question on it I want to go through. So what you want to do is you can type over your data on this one if you want to. So if you want to just type straight over your data, you can. So what I'm going to do is just do 50, then I got 100 and 150, and then 200, and then 250 like that. Now that's going to be a person's body weight, like that. And then on this one, we're going to do 9. This is a drug dosage. And 13 and 17, 18 and 21. Okay, so we're going to do that. And we're going to just do a scatter plot on that. And then we're going to get a line of best fit on this also. But then there's one other question that I want to ask you about this then. All right, before you graph that, what do you need to do? You need to reset your window, right? So it looks like for x, okay, now notice on this, x is really going to be this data. So I think it would be smart on that to go from like 0 to 250, or I'm even going to go to 300, and I'm going to scale that by 50. Okay, that's up to you how you do that, but that's a logical way. For y, what would be logical? Probably 0 to maybe 25 or something. Okay, so let's go 0 to 25, maybe scaling by 5 like that. And then we're going to get our regression equation, all right? Now, what I want you to do on this then is do your regression equation. So again, you go stat, you go calc. Let's go to option 4, which is a linear regression. Okay, and then you just, if you got the 84 like I do, you got to go to calculate, press enter, and then we'll write what we get on that then. So it looks like I'm getting y equals 0.058x plus 6.9 like that. Okay, now you could, your calculator, if you have a different model calculator, it could be slightly off, but it should be right along like that. And then let's go ahead and let's graph this. So I'm going to go have you put in the answer we got, which was 0.058x. That's given the slope. Whoops. So 0.058x, and then plus 6.9. All right, and then type graph and see if it does what you think it's going to do. So you can tell usually visually that you're doing that correctly. Okay. All right. So I don't care that you write a scatter plot on your notes or anything. I'm not going to spend time with that. But what this is saying, the other question it says is, what is the most effective dosage for somebody weighing 130 pounds? So what would you do? You just plug the 130 into your regression equation, right? Okay. So really all you got to do with this thing right here is if it's 130 pounds, you're just going to do y equals 0.058 times 130 plus 6.9. Okay, and that's what you would do is to see if this is correlated. And in medicine, this may be partially how things are done. I know in some cases, yeah, you want to give the amount that you prescribe to a patient depends on their weight, and it depends on other factors too. So if we just do that on the calculator, we'll get what that prescribed dosage would be based on this linear regression we did. Okay, so I just do that. Oops, I think I got an extra parenthesis in there. And then plus 6.9. So that looks like that's going to be about 14.4 milligrams is what you would do there. Okay, so that's the idea. If you've got a regression equation based on that data, then you could use that to answer other questions about that. Okay? All right, everybody okay with that? Yeah, go ahead.
If we have it on testing, you do want us to make a scatter plot? Do you want us to label the axes as well?
Yeah, if you were doing a scatter plot, you would want to be sure that you label what everything means. Like on this one, you'd say body weight, and then you'd say drug dosage. Okay. You'd want to tell me pounds and milligrams, because that's the way you do that in the real world. You don't want to present a graph unless it's meaningful. Yeah, do you have a question back there?
How'd you get the 14.4? Where'd you go?
Okay, again, what I did is you got the regression equation. So what you're going to do is you're going to plug the 130 in for x. So I did that on my calculator basically, is I just did 0.058 times 130 plus 6.9. So once you get your regression equation, then you can find y values based on whatever x value you want to look at then. Okay? All right? So that would be the idea. All right, everybody okay with that? Okay, well, so you'll do this on your exam too, on the calculator part. You'll do regressions, scatter plots, then you'll answer questions about that. Okay, so I'm going to go ahead and let you do the next one on your own. I don't care about the scatter plot so much, but if you did a scatter plot, you would want to write like, this would be a student's entering GPA, and then this would be the current GPA. Okay. You don't have to do the scatter plot. Mainly what I want you to do on this is just do your regression, get your calculator out, put your data in, do your regression equation on that then. Just one more time, and then that's all the time we're going to spend on that. Again, you can type over the data. That's fine if you do that. Like I'm getting messed up because I can't see very good. I think I got everything in finally. Now on the window, of course, the logical way to do this would just be go like 0 to 4 by a scale of 1. And same thing on the y-axis since it's talking about GPA, so I'll just go 0 to 4, scale of 1 there. And if I put that in then I can do, whoops, wow, what in the world, it's all clustered. Well, that's right, okay. Yeah. Actually, if you think about it, everything's clustered up there, so it's probably just as well to do this kind of like this. Why don't we just go 3 to 4? That's probably more logical now that I think of it. You can start like that if you want to. And then 3 to 4 like that. And then your data looks a little bit better. Now that looks a little bit, that's kind of what I would expect. When you're dealing with human beings, a lot of times things don't follow nice tight lines very much, okay? So let's see if you got the same regression equation I get here then. So I'll do calc. Stat calc, option 4, and we'll see what we get here. So you can fit this into a line. It's not a real high correlation on this, but that's what I'm getting. Assuming I put my data in, does that look like what you're getting? I'm afraid sometimes I put my data in wrong because I can't see very good. So 0.072x and then plus 3.51, is that what you guys were getting? Tell me, yes or no?
3.6.
Okay, so I have a feeling I put the wrong data in because it's so hard to see on this computer. Can you tell me what you got?
I got for A is 0.031.
0. What?
031.
Okay, did you guys get that? Okay,
Yeah.
I'm going to trust you then. How about the other number?
B, I got 3.67.
Okay, is that what you're getting? Okay, you guys put your data in, the teacher botched that one up. Okay, I was having trouble getting those things to match okay. All right, is everybody okay with that then? That's basically all I'm going to do with that section is do that. Now that's not highly correlated, but it still kind of basically has a correlation to it. All right, so that'll take care of that then. Okay.